Okay, so we got this integral here. Yeah, there's not much you can do here besides see that you have to make a substitution. I mean, you may be thinking integration by parts or something like that, but the truth is, and the reality is, you got to make a substitution. And I'm going to write out this as something else here. I just want you to realize this, but this is how the idea of substitutions work, right? Is that you see that you have, this composite function, right? You can call this whole thing one function itself, or you can call it two functions, because as these are multiplied by each other. The point being is you can break things up differently. And then here, you can see that if there is some way to rewrite this here. Maybe we can rewrite it as h of u du, and then we know that this becomes h of u beta a, and beta a, and I'll call this beta alpha. So what I'm suggesting is that you do a coordinate change, right? Making the substitution so you can do a coordinate change. Okay, so in this case, the substitution you're going to want to make here, do you have any colors? No, I don't. That. Why? Well, if you let that be any variable, right? You call it a. If we that was a terrible a, here's my mark. Call that a. A is equal to x squared. Then you see that d dx of a is equal to 2x, right? In other words, some people just write it like this, right? dA is equal to 2x dx. And more specifically, what we want to see is that we have x dx equal to dA over 2. So let's get it right here. Same thing, right? So now we can perform the substitution. We can rewrite this as 3 to the a over 1 plus 3a, and x times dx is the same thing as dA over 2, so dA over 2. This is a lot easier of an integral to do, as you can all see. Now, what you do here is, then you have to do another substitution. So what you can do is we'll pick a different variable, we'll call b now, let b equal 1 plus 3a. And we see that dB, I believe dB becomes out to, okay, my bad, I just had to search up the formula, just how to take this derivative. I haven't done it for a while. It is equal to, so let me just write this out here in this box. If we let y equal b to the a, then we know that y prime is equal to b to the a ln of b. Just check. Yes, there we go. And yeah, where a is your variable, right? Yep, that is correct. Okay. Sorry, I can't remember everything, right? So we see that here in this case, it's just going to become 3a ln 3 dA. Okay, so this integral can now be also rewritten as what? Ooh, so we see we have 3a here, right? Right, 3a here. We have a 1 plus 3a, so we call this b. And then we had a 1/2 here. 1/2 here, right? You can pull in the front. Now, this 3a, our new differential, right? Look at it, it has a 3 in it as well. We originally had dA, so let's solve for dA real quick. dA is equal to dB divided by 3a ln 3. So then replacing the dA, which we had earlier, with this new differential, you get dB 3a ln 3. 3a's can go away, and then we get what? Look at that. We we get 1, 2, 3. Integral, now I need to erase this now to make space. Integral dB over b, which is 1, 2, ln 3, ln b. Right? So this is your answer right here. But this is in terms of b, we want in terms of x. So we go back a step. What was b? b was 1 plus 3, so you can write this as 1 over 2 ln 3 times the b, 1 plus 3a, ln 1 plus 3a. What is a? A is this. There we go. So a lot of substitutions here for this one.